This video is going to show you how to build circuits on your breadboard. Before we start building circuits on the breadboard, we're going to measure a few things to make sure we understand the different components that are going to go on the breadboard. I encourage you to take out your Arduino, your multimeter, and the other components that we're going to use throughout the video and build along with me. Measure the values along with me. This is critical for you to really understand what's going on and not just watch what I do, but experience it as well. You can pause the video at different points to give you more time to build, and then resume the video and continue along with me at your leisure. Let's review the breadboard, and remember that the rows, individual rows themselves are connected, and then these columns, these special columns with the red strip and the blue strip on both sides, the individual columns themselves are connected. We have this red wire connected to our Arduino, and that is connected to the 5-volt plug on the Arduino. And so that's going to bring 5 volts, and it's going to give this entire column 5 volts. And then ground from your Arduino is this black wire, and that's connected to the negative column of the strip. And so that should allow us to build complete circuits starting from a positive 5 volts all the way to ground on your circuit. Now, knowing that this is connected to 5 volts, that means that if we were to measure across this positive and negative component, we should measure 5 volts. So let's go ahead and do that and make sure that that's what we're getting. So I'm going to plug in my 2 just random wires. So I pulled 2 wires from my jumper wire kit, and I'm going to plug one into the red column and one into the blue column. Then I'm going to take my multimeter and think about, if we're measuring voltage using a battery source, where are we going to position the dial on the multimeter? If you thought the red DCV segment of the multimeter, then you were correct. That's where we're going to measure because we're using batteries. That's DC voltage supply. Now remember, make sure your batteries are put into your Arduino battery pack. Make sure they're all securely in there, and then also make sure you have your battery pack plugged in. Now I'm going to use my pincher probes from my multimeter, and I'm going to connect the red to the positive side of the bus strip, and the black or common to the negative side to my ground, and that's going to measure across those components, and hopefully we should get 5 volts. So I'm measuring 4.99, which is essentially 5 volts, and so that's what I should be getting. And so I feel pretty good about the measurement and the way that this is jumping from the Arduino to my power supply. Now notice we are using the Arduino, but we're not programming. We're only using the Arduino as a voltage source. So we're not going to be using anything else with the Arduino today. We're just going to be utilizing it as a voltage source. Now if you notice on the plugs of the Arduino, you can see that there's some different voltage supplies. So if I take this red wire and move it from the 5 volts and I move it to 3.3, and notice how I still have my multimeter connected to the positive and negative side of that, it should give me 3.3 volts because the Arduino has a voltage regulator, and it takes whatever the power that's applied into the Arduino and it regulates it down to 5 volts if you use that plug, or 3.3 volts. If we have 6 AA batteries plugged up to our Arduino, how much voltage are we actually supplying to the Arduino? If each one is 1.5 volts, we're actually supplying 9 volts. So when we plug this up to the 3.3 or to the 5, we're regulating that 9 volts down to those voltage values. Now if I took this red wire and I moved it to the VN, that's my voltage into my Arduino. So again, this is 9 volts, that's VN. So if I move this red wire to VN, it should be close to 9 volts. Now mine is reading 8.29, which is closer to 9 volts, but not quite 9 volts. Why do you think that it's not exactly 9 volts? It's because my batteries are probably, one of my batteries is probably not a complete 1.5 volts. And so I'm having a little loss there. But that shows that the voltage values can change depending upon where you plug it up to your Arduino. I'm going to put mine back to the 5 volt supply, so make sure you do that as well. So I have my ground and my 5 volts, and we're going to use that in order to build our circuit. I'm going to take my wires off, and before we start building circuits, I'm going to turn my multimeter off, and I want to talk about resistors. So resistors are physical components that provide resistance. And so we talked about resistance previously in a class, and basically what resistance is the opposition to the flow of electrons. So when we build circuits on our breadboard, we're going to use resistors. If we were to not use a resistor and we were to connect, if I were to take this wire and connect it from the positive, and if I were to plug it right into the negative, I'm not going to do it because it's actually really bad. That doesn't have any resistance, so that current is going to immediately flow, and it's going to cause it to burn up, and you don't want that to happen. So we need to put resistors in our circuit. If you're looking at a resistor, you'll see that there's stripes on a resistor. So the stripes on the resistor actually have a specific meaning, and it helps us know what the value of the resistor is. And so if you look at the color chart, you can see that the stripes on the resistors actually tell you different values. So if I look at, if we're looking at this specific resistor, this is a red, brown, and then there's always a fourth stripe that's a little metallic. This one is gold metallic. You might see a gold metallic stripe or a silver metallic stripe. We'll always count that metallic stripe as the last stripe. That stripe is giving you a tolerance. So the manufacturers are going to make these resistors, and let's say if it wanted it to be a 470 ohm resistor, that metallic stripe gives it a tolerance, if it's a gold, a plus or minus 5%. So it could be a little bit more than 470 or a little bit less than 470. But the three other stripes on the resistor tell you what the value is. So if you're looking at the color chart and you're comparing it to the resistor value, if I'm looking at this one, this first stripe is red, the second stripe is red, and the third stripe is brown. Looking at the color chart and the first stripe, this first stripe relates to the first digit of the resistor. Red is a 2, so we have 2. Then the second stripe relates to the second digit of the resistor. And again, it's red, so we have 2, 2. So the first digit is a 2, the second digit is a 2, and then this third stripe, intuitively you might guess it's the third digit. Unfortunately, that's not what it is. It's actually the number of zeros that come after the first two digits. So if this is 2, 2, and then a brown stripe, which is 1, then that means it's 2, 2, and then 1, 0. So that would be a 220 ohm resistor. Let's pull out another resistor. I'm going to pull out this one. It has a gold stripe on the end, and it has brown, black, orange. So go ahead and pull the brown, black, orange resistor out, and try and figure out what do you think this resistance value is. So if it's brown, looking at the color code, we know that the first digit is 1. And then black, the second digit is 0. So it's 1, 0. And then orange, the third stripe tells you that there's 3, because it's orange, 3 zeros after the second digit. So the first digit is 1, second digit is 0, and then there's 3 more zeros. That means that it's a 10,000 ohm resistor. Let's pull out one more resistor and practice one more time. This one right here, you should have this in your kit as well. It is yellow, violet, brown. And so the yellow, if you're looking at the color code, the yellow is a 4. The violet is a 7. So the first digit is yellow, which is a 4. The second digit is violet, which is 7. So we have 4, 7. And then that brown is 1, 0 after the second digit. So it's 470, which is a 470 ohm resistor. So you can use the color code, but let's say, for instance, you can't see the colors or the colors have worn out. You can use your multimeter in order to measure the actual resistance values. I'm going to move my Arduino out of the way, and then I'm going to bring in one of these resistors. So remember, this one was the red, brown, and it had a gold stripe, so it gave it a tolerance of plus or minus 5%. And so this one should be a 220 ohm resistor. You're going to move the dial to ohms, And then I'm going to take my probes. Now, it doesn't matter what way you hook up the resistor. It can be either way. I'm going to connect my probes to it. And notice I get 0.216. Now, I was expecting 220 ohms, but I'm getting 0.217 or 16. It's kind of teetering on that number. Why is it 0.21 instead of 220 or 216? Notice at the top of your multimeter, it by default switched to kilo ohms. You see that capital K? That means kilo ohms. So 0.217 or 0.216 is 0.217 kilo ohms. Or I can convert that to just regular ohms and say 216 ohms. Now, if this is a 220 ohm resistor and I'm getting 217 ohms, then that's within the tolerance, and so that is a good resistor. And so I can know that, oh, I'm reading 217, that should be a 220 ohm resistor, roughly. Same thing with the 470. If I connect the 470, again, it doesn't matter what side you connect it to. If I look at the value, I get 0.462 kilo ohms, or 462 ohms. And then finally, I'll just show you the 10 kilo ohm that we had before, or the 10,000 ohm. And you can see that it's 9.9 kilo ohms, which is close to 10,000 ohms, or 10 kilo ohms. The last component that we're going to use within our circuitry is an LED. So we want to light up this LED. Y'all see LEDs all the time. LEDs are very popular. LEDs flashlights, LEDs on your iPhone with your light, LED bulbs. And so LED stands for light emitting diode. And so light emitting is kind of self-explanatory. It tells you that it emits light. And then the diode tells you that it's unidirectional. So it can only conduct in one direction. And so if you remember, this is what we called a semiconductor previously when we were talking about the different types of materials. So this has to be connected in the proper way in order for it to conduct electricity. Now, if you look at this diode, this LED, you can see that one of the legs is longer than the other. So the long leg connects to the positive, and the short leg always connects to the negative side of your circuit. Sometimes you might clip the legs and you might not know which one is long and short, but if you look at the LED, you can actually see how it's rounded. This collar right here around the actual LED lens is rounded here, and so that rounded side goes to positive and this flat side goes to negative. You can also see it pretty good when you look at it from a top view. Yeah, so you can see how you have a bit more rounded side here and a flat side here. That flat side goes to negative, the rounded side goes to positive. And so that's going to be important for us to know as we build circuits. So I'm going to show you how to build a circuit on your breadboard. So again, a circuit has a complete loop. So we're going to go from positive to negative. And if we're looking at the drawing of a circuit, just a simple circuit with a power source, resistor to LED, you can see that you start from your positive and then you go to the resistor. And so I'm going to plug in one end of my resistor to the positive side of my power source, which is my red column here. It can be any one of these holes along the red column. It doesn't matter. I'm just going to randomly pick one. And then I'm going to take my resistor, and don't be afraid to bend these up. You can move them around, you can bend them, you can cut them. And I'm just going to plug it into some random row. It doesn't matter which row. And then I'm going to take my LED, and I'm going to plug my LED into my one end of the LED into the row that's got the resistor because I need that to be connected. And then the other end to the ground, which is this blue strip here. That's going to complete my circuit. You can see that this goes from positive through the resistor. And then when I plug my LED up, it goes from through the resistor, through the LED, or through this row right here on the breadboard, through the LED into ground. Now if I had hooked it up backwards, Notice what happened. The LED does not light up, so it has to be hooked up the proper way. So I'm going to flip it back around and have my LED light up. So I want you to practice building different circuits on your breadboard. Always remember that it needs to go from positive to negative, and it needs to complete the circuit. Try different resistors. So we looked at, so this is the 220 ohm resistor. This one right here is the 470 ohm. So build the same circuit with a 470 ohm resistor. So I'm going to just plug it into some random row on the positive side and then to some random row. Then I'm going to get my LED. Now notice I can go before or after the resistor as long as it's on that same row. And then I'm going to plug it back into ground. Now notice it lights up as well. Try the 10 kilo ohm resistor. Let's give that a try. Now I'm going to switch things around and I'm going to actually put my LED first instead of my resistor and see if that changes anything. Does it not light up when I do that? Remember, the long leg goes to positive. The short leg goes towards the ground, so it goes to any row along your in your breadboard. And then I'm going to have my resistor along that same row, plugged into that same row as the LED, and then plugged into ground. Now it still lights up. You can see it very faintly lit up, but it's just not very bright. Why do you think that is? It still lights up, so the resistor, the order of the resistor and the LED doesn't matter. See if I switch it around, put my resistor in that column into the positive, and then I plug my LED up. Still giving me the same dim light, but still lit up. So think about this. This one is really bright. This one is actually a little less bright, if you can tell in the video. You might not be able to tell as well in the video, but it's not quite as bright as this one. And then this one is not nearly as bright. I'm going to take this 10 kilo ohm resistor off, and I'm going to use a 1000 ohm resistor instead. So that's only slightly larger than the 470 ohm. And let's see if it gets a little bit brighter. So I need to plug it into the same row as the LED, and then to the positive side to complete that circuit. Now notice it still lights. It's a little bit brighter, but not quite as bright as this LED or even this LED. This one is the brightest. So think about what that means as far as resistance. The greater the resistance, if you have a lot of resistance, then you're not able to get through as easily. Imagine yourself as the current passing through. So your current going from this positive side through this resistor, through the LED to ground, you can't go as easily through this one, but you can go really easily through this one. So the least amount of resistance gives us a brighter light because more current can pass through. Play around with the different circuits. Try building it to where you have 2 lights that light up, 3 lights that light up, all in the same circuit. Play with the different colors, play with the different resistors. I encourage you to plug things up and see what you can do in order to make these resistors work and make these LEDs light up.